Hello everyone. So today we are going to solve computer organization question. So start with the first question. So this is the first question and the question is a non-pipeline system takes 30 nanoseconds to process a task and the same task can be processed in a 4 segment pipeline with a clock cycle of 10 nanoseconds. So we have to determine the speed up of the pipeline for 100 tasks. So in this question, firstly we have to find the time with the help of non-pipeline system. After that we have to find the time with the help of pipeline system. So start with the answer. So firstly we should know what is the speed up of the pipeline. So the speed up of the pipeline can be evaluated with the formula with this. The execution time of the non-pipeline upon execution time by pipeline. Okay, so firstly find out execution time with the help of non-pipeline. So the formula for execution time in case of non-pipeline is n into tn. N means number of tasks and the tn is the time to execute a task. So in this question we have given in case of non-pipeline system the time given for process a task is 30 nanoseconds. Okay, and the number of tasks is 100 tasks in both cases. In case of non-pipeline and in case of pipeline the task number of tasks given are 100. So the execution time in case of non-pipeline is equal to 100 into 30 nanosecond. 100 is the number of tasks, that is n, and into tn means the time to execute a task. So in case of non-pipeline the time to execute a task is given as 30 nanosecond. So 100 into 30 is equal to 3000 nanosecond. And in case of pipelines, the formula for the execution time is k plus n minus 1 into tp. Here k stands for the stages or the segments and n is the number of tasks and the tp is the cycle time. So in the question we have already given the stages or segment are 4 segment. Okay, that is the k is equal to 4, n is the number of tasks, that is 100, and the tp is cycle time. So in case of pipeline the cycle time given as 10 nanosecond. So the execution time in case of pipeline is equal to 4 plus 100 minus 1 into 10, that is 1030. So now we have the execution time. We already evaluated the execution time for the non-pipeline and the pipeline. So the speed up is equal to 3000 upon 1030. 3000 nanosecond is the time in case of non-pipeline and the 1030 is the execution time in case of pipeline. So we get 2.91 is the speed up. Okay, so according to the question the option will be D, that is 2.91. So this is very easy question. In this question we should only know the formula, how to evaluate the execution time for the non-pipeline system or and the pipeline system. So moving forward to the next question. So the next question says that the reduced instruction set computer, that is the RISC, characteristics are. So these are 4 characteristics given in the question. So we have to find which one is the RISC characteristics. So firstly we should know what are the characteristics for the RISC computer. So these are some characteristics we should know. So the first characteristics is RISC is architecture design of the CPU. Okay, second is supports more number of registers. Okay, it supports fixed length instructions. Fourth is it support less number of addressing modes, and the fifth is it supports cycle per instruction, that is CPI is equal to 1, and sixth is it supports successful pipeline. Okay, next is it is used in real time application. Eighth is it contains smaller instruction set, and ninth is it uses hardwired control unit. So back to the question. So in this question, the first characteristic is single cycle instruction execution. So this is correct. This is the characteristics of RISC computer. So now we got that is the A option is correct. So find in the options which contain A option. So first 1 and 3 contain A option. So the answer should be in these options. So now the second option will be against the B and the D. So we have to find either B is the characteristics of RISC computer or the D. So B option says that variable length instruction format. This is correct. This is incorrect because RISC contain fixed length instruction. That this one, it support fixed length instructions. So this one is false. So according to the option, the one is the wrong. So the option will be third. Okay, because A is a single cycle instruction execution, this one correct, and the D is efficient instruction pipeline. Okay, this one is correct. So according to the question, the answer will be C option. Okay, so moving forward to the next question. So in this question, we have to match the list 1 and list 2 with one another. So the A option is a micro operation. So we already knew that the micro operation is the elementary operation in the hardware. And in the list 1, the option will be D. So A is matched to the D. Second is B, micro programmed control unit. So we already knew that the control memory is available in the micro programmed control unit. So for the B, the option will be third. Okay, and in case of C, now we have to check in the options which one is to be matched. So A is matched to the 4, this one 1 and 2, and the B is matched to the third. Okay, fine. And now check the D option, the D, that the micro instructions. So we already know that the micro instruction contain one or more than one micro operations. It means it specify the micro operations. So the D match with the 1. So in the options we have D matched with the 1. So the option will be A. Okay. So the next question is, so in this question, in a list 1, we have given the isolated IO and the memory mapped IO. So these are two the bus configurations, and in case of isolated IO, the common bus and the common address space will be given, but the different control signals are used for memory and IO. And according to in list 1, the option is 2, that's a separate instruction for IO and the memory communication. So A is matched to the second option, and next one is the memory mapped IO. So in case of memory mapped IO, it uses the common bus and the common control signals, but the unique address space. So in the list 1, the option will be for 1. So the B matched to the option 1. So in the options we have given the C, that is A is matched to second and B is matched to 1, and the C is matched to the 4, and the D is matched to the 3. So this option is different from the other options, so the answer will be C. So moving further to the next question. So in the next question we have given the question is, which of the following inter-process communication model is used to exchange messages among cooperative processes? So this is very simple question, because queues will not be used in case of exchanging messages. So the option will be C option. Okay, so moving forward further to the next question. So this question is very important. So this question says that the following program is stored in the memory unit of the basic computer, and give the content of accumulator register in a hexadecimal after the execution of the program. So we have to tell the accumulator, we have to find the content in the accumulator register after executing this program. So start executing this program. So the first location, that is 010, says that the instruction is CLA, that is the clear accumulator. So firstly accumulator will be cleared, this one. The second instruction, in the second location 011, we have given instruction is add 016. It means that we have to add the content of accumulator and the content which is given at location 016. So we have to find the content in location 016. The content which is present at location 016 is C1A5. Okay, so this will be added with the content of accumulator, and at present the content in the accumulator is null, or accumulator will be cleared in the previous step. So it contains 0000, and next content is present at location 016, that is C115, and it will be added, and after added we get C1A5. This will be stored in accumulator, this one. Okay, now the next location is 012, and the instruction is at location 012 is BUN 014. It means that BUN means branch to the location 014, that is this one. So we have to branch to the location 014. Okay, fine. And at location 014 we have given instruction is and 017. It means that we have to perform the AND operation with the content of accumulator and the content which is present at location 017. So at 017 we have content 93C6, this one. So we have to AND the content with the accumulator. So accumulator contains C1A5, and the content which is present at location 017 is 93C6. So now we have to perform the AND operation. Okay, so firstly convert these numbers into hexadecimal. So C stand for 12. So 12, we already know that 1100, and 1 is 0001. A is the 10, that is 1010, and 5 is 0101. Okay, so this C1A5 is converted into binary number, and next is 93C6. We have to convert this number into the binary number, and after converting the binary number into binary number, we get 1001, 0011, 1100, 0110. Now we have to perform the AND operation. So recall the AND operation. So in case of AND, if we get 1 then we get the 1 in the output. Okay, so after performing the AND operation we get 1000, 0001, 1000, and 0100. This one is 8, this one is 1, this one is 8, and this one is 4, this one. Okay, so after performing the AND operation with the content of accumulator and the location and the content which is present at location 017 is 8184. So put this value 8184 into the accumulator, 8184. Okay, now this one is performed. Okay, and then put this one into accumulator. Okay, fine. The next question is 015, and the instruction at location 015 is BUN 013. BUN means branch to location 013, this one location, and at location 013 we have given instruction halt. So we have to stop this program, and after evaluating this program we have got in the accumulator the content is 8184. So according to the question, the option will be D option, 8184. After executing the program we get in the accumulator is 8184. So this is all about today's question. So please subscribe, share and like the video. Thank you.